In today's video, I'm going to be talking about my batteries. How far can I go discharging my batteries? So right now, I was waiting for this so that I can able to show you guys what's going on with my batteries, my Sanyo Lithium batteries made in Japan. So guys, let's check it out and see. This is a Volkswagen e-Golf made by Sanyo. So let's check it out. These are my batteries right here. This is a Volkswagen e-Golf, and is 8.544 kilowatt of lithium power storage. I have here 24 volts configuration. So what I've done, I want to give you the statistics on my batteries or every detail. So these batteries, they have 8 modules in these batteries, I suppose. And each cell, the max charge is 4.1 volt per battery, per cell. And nominal voltage, which is 3.6 volt. And the minimum voltage is 3.0. So it's 3 volts. That means the battery is dead. Okay, and this battery can peak up to 600 amps peak time, and it runs continuous at 350 amps continuously. And like I said, the manufacturer is Sanyo, Japanese company. And if we have to do the math here, okay, each module, there's a module right here, a module. So I have 8 of them, 4 in parallel and 4 in parallel and series them. So what I'm gonna do here, I'm gonna break it down for you to understand, for other people who have a hard time understanding, or maybe they're just learning how this thing goes. And I want to show you guys, like I said earlier, 4.1 volts times 4. If you put four batteries in parallel, 4 in parallel, 4 in parallel, series them, that's supposed to give you a 4.1 times 4 is 16.4 volt. Each module here is 16.4 volt, like I said. So if we have 2 batteries connected in series for 24 volt, that will give us 32, because the 16.4 times, if we go 16 point, okay, if we decided to go do again, break it down into the cells, we come back with 4.1 times 8. That gives us 32.8 volts when you have 2 batteries. So remember, 16.4, one battery, 16.4, sorry, together, that gives you that 32.8. So just it's a matter of just saying 4.1 volt times 8. That gives you this. Okay, that gives you a 32.8 volt. That's the max charge for this battery. So if the nominal voltage, if you add 3.6 times 4, that gives you 14.4. That's one battery, 14.4. If you put them in series, 14.4, that will give you 28.8 volt. That's the nominal. When you get there, your battery is at the nominal, which is sitting at a 3.6 volt per cell. It's a 3.6 volts per cell if it goes to 28.8. Okay, if it goes 28.8, which is a nominal, that means we are sitting at a nominal voltage, which is a 28.8. So let me stop right there, bring you right here to the machine and show you the voltage we are sitting at. That's why I said, how far can we go with these batteries? 28.67. So the number I told you is 28.8. Okay, 28.8 volt. If we go out here, that's exactly 28.8 volts. So we are just sitting at a nominal voltage of these batteries, which right now like I just gave you the calculation. So that means each battery is now at 3.6 volt times 8 of it. That will give you 28.8. So let's check the state of charge. Because of that, look how far I can bring my state of charge when it comes to these batteries. How far the state of charge can go. 47. When he hits 47%, that means I'm sitting at 28.8 volt, which is right there. 28.8 volts. So I just want everybody to understand how powerful are these batteries. And this is this battery bank is just a 300 amp hours. Let's see how much we already drawn from the battery. See that? That's out. 157 amp hours off the batteries. That's what already took. So it's half of that battery. Half of this battery bank right here. So the capacity is 300. So we just took about half of this pack or this power wall. We just took half of that capacity, which 150, that gives you 300. So 157 we already took off from 300 amp hours, this stack. So let's keep going. I break that one down, and if we let this battery go to 3.0, so if you get to 3.6 times 4 is a 14.4 per battery. This one here, 14.4. Okay, so that's a nominal voltage. When we allow that to go to 3.6 volt times 8, if we double them now in 8 cells, that give us that's 2 batteries, these ones. So we just move forward by for series, and then that will give us that, and that will give you 3.6 times 8, I will get 28.8. That's what we're showing on the record right here. On the record right there, guys, right there. We're sitting right there. Okay? So right now, we're sitting at 3.6 volt per cell times 8. That gives us a 28.8. And back to the battery here, because I want to break this one. I think I'll be having some questions. And if we go back here, we drop this battery to 3.0. Uh-oh, that's a bad deal. 3.0 times 4, that gives us one module right here is a 12 volt. So it's considered the battery is dead. Okay, but if 2 of them, 3.0 times 4 times 8, sorry, that'll give us a 24 volts, which is this thing configured 24 volts, and we are down. The charge controller or the inverter right there is going to shut down. It's going to shut down before that because I set it up to 24.4. I don't want it to go 24 volt. 24.4, the system will shut down, and it has never happened yet with these batteries. I don't let them that way. So being said that, these are all the configurations for the cells. So if these batteries, four batteries, you know, the max is on a thinner cell is is a 8.2, nominal 7.2, minimal 6.0. Okay, at a 12 volt battery. I'm taking as a 12 volt battery. So if you go 8.2 times 4, because if you add 2 cells in series, I was trying to explain, 2 cells in series, which is a 4.1, that will give you a 8.2. Okay, 8.2 times 4, let's put 4 cells of 4.1 times 4, that will give us the 8.2 times 4, that will give us the 32.8 And if we bring it down to the nominal volt, which is the 7.2 times, if you divide that in the nominal, I already read all those numbers, I hope you write them down. 7.2 times 4, that will give us the 28.8. I'm talking about the 24 volts pack now. This one, these two batteries are 24 volts. Okay, and if we decide to bring it down, I'm just trying to break it out the best I could. 6.0 times 4, that give us the 24 volts. So this battery is completely dead. Okay, you don't want to get to that point. So this is how far I can go down with my batteries. These batteries can go all the way down. And trust me, guys, this one, it would have been for 12 volt configuration. That would have been a massive, because we have a 300 amp hour at 24 volt at 8.544 kilowatt lithium. And if it was a 12 volt, that would be a 600 amp hours. That's a lot of power. That's a lot of power for 12 volts, and that would be a sweet system. I save these batteries particularly for the functionality I can enable is flexible. I can go all this in 48 volt. Okay, if I go 48 volts, so it's 12, 12, 36, 48. 12, 12, 36, 48. So I have two strings of 48 volts would have been at 700. This battery, okay, for example, let me just clear this. This battery is a 75 amp hour. Just this guy, a 75 amp hour. This battery, which is 1. I think. Hold on, let me see here. Maybe I can bring it down for you. You can able to see. So this battery is a 1.086 kilowatt. So per battery. So 1068 watt hours on each battery, on each module. Okay, so, and these batteries, you can't believe these batteries are manufactured at 05/04/2013, and it's giving me an optimum performance like this. And you guys already see how impressive are these batteries. And it's 2013 is manufactured, and it's still giving us it's made in Japan. Guys, I'm just giving you what this battery has given me. And I cannot believe, or I'm not going to even trade that for anything, which I wish I had more capacity. If you have the chance, or you can able to buy a car, Volkswagen e-Golf, and strip that car and take the batteries, it worth every penny more than the car, because you're going to be having an outstanding performance on your batteries. Your batteries alone worth a lot of money, because I pay a lot of money for these batteries. But guys, you won't believe this. This is going to be an outstanding pack if you have the entire battery. I wish I have the entire, if I have the possibility and get hold of a vehicle like that, instead of me driving it, I'll strip the batteries off and take the batteries and sell the car, or maybe salvage the car. Get someone can use it for parts or something. Or maybe I'm not gonna able to sell it by part because I don't have time for that. But I'm trying to sell it so someone else can buy the entire vehicle for parts. All I care about is the battery, because that's how these batteries have proven themselves with all that is going on here. You can't believe this. 28.8. We've been running this system approximately, is coming to the 3 days. We already started, because we are sitting right now, it's already past the hour. What is that? Over 10 at night. Okay, it's 10 at night, and look at that. It's going to the 3rd day, because it's getting hot here, and the more it's getting warmer in the house, and the more the refrigerators continue to run. Because when it's cooler, these are all the tricks I'm telling you. If it's cooler in your house, the compressor don't kicks in your with your refrigerator or freezers, they don't run at all. But when its temperature is getting higher, Okay, now you just go. See that? You just move. So this is from the last time these batteries were charged. No, I don't charge them full. I charge them up to about 90%. Could you imagine if I turn this one all the way max so that they can be up to about 100% capacity or 100% state of charge? You can see 100%, but I set this battery not to charge all the way 100%. They charge only at 90%. You just saw that. It just changed to the third day. So that's 3 days already at, look at the thing, the state of charge at 47, and we just sat at 28.8 nominal voltage. 3 days. I've proven, not me. I can't tamper with this. This thing is counting the watt hours and counting the days and everything that was taken off from the battery. You saw what is already taken off from the battery, which is a 150 something, 57. I think so. Yeah, 159 now. 159 amp hours off from the batteries, which we already took half of the capacity of the battery bank. Well, this is how I'm gonna wrap up the video here because you can trick this. What I've done, I turned the solar off when these batteries are charged because I want to make sure energize the batteries 3 days without being charged and flip the switch again for that guy right there and getting them all the way charged. This is how I'm doing it because I don't want to recycle. I don't want them to just keep on tap, tap, tap. No, trickle charge, trickle charge. I just want them to exercise the batteries in a way that they can able to get something. Hey, check that one out. Look up there. No more holes. No more holes. It's all up. Now I can able to show you guys. Look at that. It's cool, right? Well, this is how we do right here, JW Solar USA. Thanks for watching. Love you guys all. Live here from the channel in Minnesota. Always stay around and make sure you like and subscribe so that I can bring you more content here live from the channel. If you like my videos, share them. Share the videos and, with friends, other people who are looking at doing renewable energy and they think they need answers, or they want to make a setup like this, or they want to find batteries like this. Hey, refer them to my channel. Show them what batteries can do. I'll consider these batteries right now. I'll have to pronounce these batteries soon. Them are the best batteries in town or around the globe. Thank you.